Hello and welcome to your Monday math. I know if you look on my screen, it's showing Sunday, but it's Monday. So do Monday math. It is Monday, February 24th, 2025, and this is your warm-up question. Identify the missing length and width for the shapes below. Then find the area and perimeter. So look at this shape, find the missing length, top to bottom, and width, side to side for the shape below, then find your area and perimeter. While you're doing that, let me go through the rest of our warm-up page. It is Monday, February 24th. I know, it's technically Sunday, 2025. In case you forgot, I'm your teacher, Miss Smith. My email is tsmith@ellisaway.org, and my number is 682-777-9474. Our class expectations, we're going to listen carefully so that everyone can learn. E, enter prepared and stay engaged. A, arrive on time. R, be respectful of your learning and learning of everyone else. And N, never, ever, ever give up. We're going to be safe with our learning. That means no sharing outside links or personal information appropriate with our clothing, conversations, and backgrounds. Friendly, helpful, and encouraging at all times, and with our environment. No distracting conversations in the chat, no distracting noises on the mic, and no distracting images in the background. With that being said, remember, you are identifying the missing length and width for the shape below. Once you do that, find the missing area and perimeter. Go ahead, pause the recording, find those missing lengths and widths. Sorry, my brain is done for today. And then unpause and we'll go over the answer. Alrighty, doodles and apple strudels. What was your answer? What do we know about this? So before we even say what is our answer, let's talk about what do we know about this shape. Let's look at this shape as a whole. Let me change my pen color. What do we know about this shape? If we're looking at this shape, we can say that this shape is a what? Is it a circle? Is it a square? Is it a rectangle? Is it a star? Is it a triangle? It is a rectangle, yes. But it is a rectangle made up of what? Because if you look right here, it is actually made up of two shapes. So it's a rectangle made up of two different shapes. So what are those two shapes made of? So shape one, actually before I turn that on, I should do this. Shape one is a rectangle, and then shape two is a square. Very good. And yeah, you're like, very good. Who's answering that for you, Miss Smith? And I'm like, no one. I'm the magical kids who are answering. That's who's answering. So when we are finding, I'm not re-recording because I've already done this re-recording 3 times. So you get what you get right now, my sweet friends. So once we identify, yes, this is a rectangle, a larger rectangle that is made up of one smaller rectangle and one square, we need to ask ourselves some more questions. What do we know about rectangles? We know that a rectangle when not re-recording. We know that with a rectangle, opposite sides are equal, right? And so when we have opposite sides that are equal, that means that whatever our length is, our length top to bottom, whatever our length is, on one side, if we have a length for the left, it would be the same for the right. Whatever our width is from side to side, whatever it is for the top, it would be the same for the bottom. If we have a width for the bottom, it would be the same for the top. So opposite sides are always going to be the same. So how do we find those? So let's look right here. They've already given us the length on the left side. Let's look on the right side. We don't have a length. But is it the same length once we combine that rectangle and that square? Yes, it's the same length. It didn't change anything. So we can say the length is still going to be 3 inches. So I can put 3 inches right here. And then when we look for our width, we don't have a width on the top. Now, when we combined, or when whoever created this combined the rectangle and the square, that's where really the width kind of changed, because the length never changed. It was always the same. They didn't combine anything, but the width is where we added on. The length they didn't add anything on to. So let's look right here. We had 3 or 6 inches and 3 inches. When we combine something, what operation do we do? Do we add, subtract, multiply, or divide? When we are combining something, what operation are we doing? What? What did I hear y'all say? Like all the way over in Texas? Yes, when we're combining, we're putting something together, we are adding. So what are we adding? We're adding 6 plus 3. So 6 plus 3 is 9. So because whatever the width is on the bottom, I can just put 9 inches on the top. I don't have to put 6 plus 6 here, 6 here, 3 here, 3 here, and then add. I can just do add down here and then put my 9 up top. Now that I know my lengths for all 3 sides, I can find my area and my perimeter. So let's start with perimeter first. Okay, we're going to start with perimeter first, and then we'll move on to area. So perimeter, once again, goes around the outside. Remember, perimeter is kind of like the fence that holds the area grass in. That's how Ms. Smith always remembers it. If we think about perimeter, it's kind of like that fence that holds Millie, our wonderful puppy dog, in our area. So we don't want Millie to run out, so we put a fence in. So perimeter holds Millie in so Millie doesn't run away. So what is the perimeter of this grassy area that's going to hold Millie in? We need to add up each of these lengths. So we need to add up 9 plus 3 plus 9, because we added these two together. So now we just have the 9 plus 3. So we have 9 plus 9 plus 3 plus 3. What is your perimeter? Because we're adding those together. 9 plus 9 plus 3 plus 3. Give me 1 second. I'm changing my pen. Hopefully you guys have already done this part of the math. So when we have 9 plus 9, what do we get? We get 18. 18, or 3 plus 3, what do we get? We get 6. 18 plus 6, what do we get? 24. Now, because we had 2 groups of 9, 9 plus 9, we could have said 9 times 2. And because we had 2 groups of 3, we could have said 3 times 2. 3 times 2. It's the exact same thing as saying 9 plus 9 plus 3 plus 3. That's the exact same thing that we're doing. We're just saying there are 2 groups of 9. 9 times 9 is, what is 9 times 9? That is 18. Give me 1 second. I'm going to change my pen color. 9 times 9 still is 18. 3 times 2 still is 6. We still have to combine 18 plus 6, and we still get 24. Now, it's not just 24, it's 24 inches. Keep that in mind. So, what is our perimeter of Millie's grassy area? What is not going to let Millie run away? The perimeter is 24. Now, we need to find the area. How many inches? So let's face it, Millie's probably not going to have fun if it's only in inches. How many inches does she have? So when we are dealing with inches or with area, we are multiplying our length from top to bottom times our width. What was our length? Our length was 3. So 3. And what was our width? 9. I'm about to sneeze, so give me 1 second. Thank you. Sorry, you didn't need that. All right, so we had now that we have our 3 times 9, because remember, all of that's saying is we are saying if we built an array, then that's not really how it should look. This is how it would that's kind of how it would go down. That's really not how it would go down because, Miss Smith can't draw it to say Millie was going to run out of that area. Millie would run out of that area if I had to draw that in. But 3 times 9, what would be 3 times 9? It would be 27 inches. Which is because we have run out of time with our warm up. So that is our area. All right. Today, we are going to talk about how we can classify and explain the differences between two-dimensional shapes. Now, in second grade, even in first grade, even in art, you guys have been talking about 2D shapes. 2D shapes are things like this piece of paper that are flat, versus, I've lost it, versus my earbud container. That's a 3D shape. It is not flat. 2D shapes, flat. You cannot see. If I were to put this up against the wall, you would not know the difference. You wouldn't be able to tell the difference between the paper and the wall. It's flat. If I were to put my earbud container against the wall, you could see it. It would stick out. So today, this week really, we're going to talk about the differences between 2D shapes, those flat shapes, and 3D shapes, the shapes that kind of pop out from the wall. But today we're really going to talk about those differences between 2D shapes, and then we're going to classify, meaning group, and then explain those differences. Before we do that, I'm going to tell you right now, there are a lot of vocabulary words on this page. We're not going to go through all of these words right now. I'm going to go through them. I'm going to kind of do my best to say the words. But a lot of these words you're really going to explore towards the end. So the first one is a closed figure. A closed figure is a shape where there are no open endings. Next one, decagon, a closed shape with 10 straight sides and 10 vertices. Docagon, a closed shape with 12 straight sides and 12 vertices. An edge, a line or side that joins corners or surfaces of a shape. So really it's just the line of a side of a shape. So the line of a shape. So if we're looking at this being a shape, edge would be just kind of the line of a shape. Do that one more time. I'm going to get a paper cut. A hentagon is a closed shape with 11 straight sides and 11 vertices. If you look at all of our pictures for each vocabulary word, every picture, every shape, or every vocabulary word has a picture to represent it. And even with the edge, there is a picture of highlighting what an edge would look like on an actual shape. A heptagon, a closed shape with 7 straight sides and 7 vertices. A hexagon, a closed shape with 6 straight sides and 6 vertices. A nanogon, a closed shape with 9 straight sides and 9 vertices. An octagon, a closed shape with 8 straight sides and 8 vertices. A pentagon, a closed shape with 5 straight sides and 5 vertices. A polygon, a flat or plane. So polygon is flat or plane, meaning flat, going on forever. 2D closed shape bound with straight lines. So if you look right here, a polygon, it's flat, it's closed, and it's closed, bound, closed with straight lines. A rectangle, closed shape with 4 straight lines and 4 vertices. A square, a closed shape with 4 equal straight lines and 4 vertices. Should have put it with the rectangle, opposite sides are equal. Trapezoid, a closed shape with 4 straight sides. One side is parallel and 4 vertices. So later on in the week, we're really going to what does that mean? One side is parallel. Triangle, a closed shape with 3 straight sides and 3 vertices, and vertex or vertices. So one second, I'll explain that. So a vertex is a point or corner where 2 or more lines meet, or edges or sides meet. So if you look right here, like that I know it's kind of small because I had to fit everything in, but that where that red dot is, and then you have like these 2 green lines meeting. Where that red dot is, that's a vertex because that's just like where the point is. So where 2 lines of the triangle meet, that is one vertex. But a triangle has how many? We have 1, 2, 3 vertices. So if a shape only has 1 point where lines meet, it would only have 1 vertex. But if it has more than 1, it would be called a vertices. If you notice, each of these shapes have multiple vertices. And if you really pay attention, if it has 3 straight lines, it has 3 vertices. If it has 4 straight lines, it has 4 vertices. However many lines it has connecting it, that's however many vertices it has. Pay close attention to that, guys. So, look at all 3 of these shapes. What do these 3 shapes have in common? Pay close attention. And not at Mildred barking in the background. Very disappointed in her right now. What do these 3 shapes have in common? All right, now that you think you might know the answer, what about these shapes? What do these shapes have in common? How are they different from the previous shapes? Messing up. Making me think. But what if I ask you about these shapes? What do these shapes have in common? And how are they different than the 2 previous sets of shapes? Which of these 3 sets of shapes would be considered a polygon? If we were looking at all 3 sets of shapes, which of these 3 sets of shapes would be considered a polygon? Or would be considered polygons, not a polygon. Now that we see all 3 sets kept together, which set would be considered a polygon? Would it be set 1, set 2, or set 3? You said set 1. You are correct. But why? Let's explore. It really is an open and closed case. How do we know if a shape is open or closed? And that, you guys, you just blow my mind. You ask the best questions even when you're not in class. If you can take a pencil and trace a shape all the way around without ever lifting your pencil and the shape never breaks, then the shape is closed. It is a closed shape. But if you try to trace a shape and there is a break in that shape, then the shape is considered an open shape. So look at the chart below. One side is open and the other side is closed. So when you think about the difference between an open shape and a closed shape, then a closed shape, there are no breaks. An open shape, there are breaks. Now go back and look at each of these. Why is the top and the bottom, why is the top considered a set of polygons, but the bottom isn't? Exactly. Because there are, if I were to, and okay, we're going to have to pretend I can draw a straight line, and I can do it without ever lifting my pen, but I can draw without ever lifting my pen, right? I mean, not the best, but I could try to do it for the top one. Okay, that one we couldn't even try. But the top one, they were all three closed shapes. But this one, that's not even a closed shape. Like I don't even know what I did to make that a closed shape. And then I would have to like loop around maybe to maybe make that a closed shape. Maybe? Oh. And then this one, do, no, I can't even. I'm done. And then this one, that looks like a fun ride though. Like if that's a roller coaster, woo, free ride. But other than that, yeah. So based off of open and closed shapes, I can see why this one, that what would definitely be a set of polygons versus this one. Yeah, get out of there. Don't want you in there. All right, let's go back. So open shapes, there's a break. I cannot trace the shape at all because there is a break in that line. I have to lift my pencil up. Closed shape, I could trace that shape all day long if I wanted to because there aren't any breaks in the line. So we know a polygon is a closed figure, but it also is made of straight lines. So it has to be a closed figure, but it also has to be made of straight lines. There can't be any curvy, hands in the air, free ride, dips and turns and zips and zabs. It has to be straight lines. Just like these right here. All of these shapes from the first set were made of straight lines. I mean, we're going to have to pretend like Miss Smith knows how to draw a straight line. Yeah, that's not happening today, now is it? But all of these are made of straight lines. There we go. And there we go. But when we compare them, let me clear this one off. Oops. But when we compare them to, when we compare the first set to the second set, so we've already said this one, you're out of there. But when we compare the first set to the second set, we have a circle. Woo! We have one straight line and then a zippy zoo around, and then we have a kind of straight line, and then we zip around. Yeah, so second set, get out of there. That is why our first set is definitely this set of polygons. So we know that polygons are made out of closed figure. They are closed figures, and they are made of straight lines. So what is a polygon? What you're going to do is you're going to go through each shape, and you're going to identify the shapes looking at each one. You're going to mark off the shape. Is it a straight? Is it made of straight lines? If it is, mark it off yes. Is it a closed figure? If it is, mark it off yes. Ask yourself, is this shape made of straight lines? Nope. Is it a closed figure? Yes. Actually, you only have to mark no. You can just check mark yes. All right. Is this made of straight lines? Yes. Is it a closed figure? No. Straight line? Nope. Closed figure? Yes. The rest you can do on your own. So pause, complete that. All right. So let's compare our answers. We did the first 1, 2, 3, 4 together, and you were supposed to work on the last 5 on your own. So this one, straight lines, closed figure. I got check mark, check mark. What about you? Bottom row, first one, straight lines, no. Closed figure, no. So nope, nope. All right, next one, straight lines, yes. Closed figure, yes. So check, check. All right, third one, bottom line. Straight lines, nope. I mean, there were like maybe 1, 2, but it wasn't full of straight lines, so nope, we can't do it. Closed figure, nope, nope, nope. And then our rectangle at the bottom, straight lines, yes. Closed figure, yes. So check, check. Alrighty, Rue. Let's keep moving on. So what is a polygon? We know it must be a closed figure made up of straight lines that are connected by a vertex. A vertex is a point or a corner where lines or sides meet. We talked about this when we looked at the vocabulary, but once again, it's where those lines meet. And if it has 3 lines, it will have 3 vertexes or vertices. So this triangle has 3 lines, so 1, 2, 3. So it has 3 connecting points. So it has 3 vertices. So what are we doing? You're going to first identify the sides of the shape. So, So let's look at the first one. So how many sides does the shape have? 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's 3 sides. All right, and then look at the vertices. So those points. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it has 3 sides, 3 vertices. All right, so if you look in your drop down, open it up, you have your vocabulary. Let's see, can we find a shape like that? Let's see. Right there, it's a triangle. So I'm going to go back in and I'm going to write triangle. And I'm going to pretend to write better than that. There we go. All right, so now let's count these. So count my sides. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 4 sides. Now ask yourself, do all of these shapes, are all these shapes the exact same? I mean, I definitely know this and this. I know that's a rectangle and I know that's a square, but these don't all look exactly the same. So we're going to go look at them. So, all right, let's count the vertices. 1, 2, 3, 4. 1, 2, 3, 4. So they all have 4 vertices. So let's go look at our vocabulary list. The only thing I am going to say is a trapezoid, because it's a closed shape with 4 straight sides and one side is parallel. Parallel is where, like, I think that probably might take us out though. Where one side would not meet at all. I think this one might take us out though. I'm just going to put trapezoid here. Trapezoid. Trapezoid. All right. Now, for each one, you need to create your own shape. So I'm going to do this and then this. All right. And then you'll do the same for this one and for this one. Make sure you use your vocabulary list. And then finally, your exit ticket, cross out the figures that are not polygons and then draw 2 new polygons in the green box. Using complete sentences, explain why you crossed out and drew the new shapes you did. Sorry, bad grammar. All right. With that being said, my friends, I will see you tomorrow when I am back from my conference. Love you all. Hasta la pasta. Bye.